Have you ever looked at your own hands and wondered, where did this all come from? Not just you, or humanity, but all of it, every tree, every insect, every microscopic creature. What was the very first spark of life on our planet? This is the greatest mystery of all time, the question of our ultimate origin. For centuries, we've searched for answers, looking to the stars and deep into the code of our own cells. Today, on Beast Stories, we embark on a journey for billion years into the past to uncover the secrets of the first life on Earth. Welcome to our channel, where we explore the most fascinating stories our world has to offer. Imagine a young Earth, a chaotic and hostile world. Volcanoes spewed gases into the atmosphere, oceans churned with a chemical cocktail, and meteorites constantly bombarded the surface. It's hard to picture life beginning here. Yet, in this violent environment, something incredible happened. The non-living became living. This process, known as abiogenesis, is the central puzzle we need to solve. It's not about evolution, it's about the moment before evolution even had anything to work with. How did a random collection of chemicals organize itself into something that could grow, react, and, most importantly, replicate? Our story begins in what scientists call the primordial soup. This was a warm, shallow body of water, rich in simple organic compounds. Think of it as a planetary-scale chemical laboratory. In 1952, the famous Miller-Urey experiment tried to recreate these conditions. They mixed water with methane, ammonia, and hydrogen, gases believed to be in Earth's early atmosphere, and zapped them with electrical sparks to simulate lightning. The results were astounding. Within just a week, they found amino acids, the fundamental building blocks of proteins. This was a groundbreaking moment. It proved that the basic ingredients for life could form spontaneously under the right conditions. The primordial soup wasn't just a theory anymore. It was a plausible starting point. Prebiotic chemistry was possible. But having the ingredients is one thing, baking the cake is another. Life needs more than just loose amino acids. It needs a way to store information and to carry out chemical reactions. This brings us to the RNA world hypothesis. Today, DNA holds our genetic blueprint, and proteins do most of the work in our cells. But DNA is complex and needs proteins to replicate, while proteins need DNA to be made. It's a classic chicken and egg problem. RNA, however, is a jack of all trades. It can store genetic information like DNA, and it can also act as an enzyme to catalyze reactions, much like a protein. Many scientists believe that early life was based entirely on RNA. These simple RNA molecules could have self-replicated, competing and evolving in the primordial soup long before DNA or proteins ever existed. Now, we have self-replicating molecules, but they're still just floating around. To become a true living organism, you need a container, a boundary separating you from the outside world. This is where the first cell, or protocell, comes in. The key ingredient here is lipids, which are fatty molecules. In water, lipids naturally form spheres, creating a tiny bubble. This is called a lipid membrane. This simple bubble could have trapped those self-replicating RNA molecules and other useful chemicals inside. Suddenly, you have a self-contained unit, a tiny factory with its own internal environment, protected from the chaos outside. This was the birth of the first cell, a microscopic pioneer that would change the planet forever. But the primordial soup isn't the only theory. What if life didn't begin in a warm little pond, but in the crushing darkness of the deep ocean? Another compelling idea points to hydrothermal vents. These are cracks in the ocean floor that spew out hot, mineral-rich water. They create incredible chemical gradients, a constant flow of energy and raw materials. These vents could have acted as natural chemical reactors, providing the perfect nursery for life's first complex reactions to take place. The constant energy supply and unique mineral structures might have been the perfect scaffolding to assemble the first protocells, sheltered from the harsh radiation bombarding the Earth's surface. So, we have these incredible theories, each painting a different picture of life's genesis. From a lightning-struck soup to the deep-sea vents, the journey from simple chemicals to a complex cell is a mind-bending puzzle. We've explored just the beginning of this epic story. In our upcoming videos, we'll dive deeper into how these first cells evolved, the rise of DNA, and the great oxygen catastrophe that changed our world. But this all leaves us with one lingering question. If the building blocks of life can form so easily, Could it have happened somewhere else? On Mars, on the moons of Jupiter or Saturn? What do you think? Let me know your thoughts in the comments below. The search for our origins is also a search for life elsewhere in the cosmos. Thank you for joining us on Beast Stories. If you found this journey as fascinating as we did, make sure you're subscribed so you don't miss what's coming next. We have so many more mysteries to explore together. See you in the next one.